tab. A sphere is the set of all points in space that are equidistant from one point. Which would be considered the center of the sphere. Just like a circle, a sphere has a radius, but the radius could go anywhere from the center to the outside of the sphere. So if you're going from the center and hitting the sphere, you've got a radius. And the radius should be equidistant, or should be the same length regardless of which direction you go out from the center. You also have a diameter. So if the radius is from the center to the outside, the diameter is from any point on the outside to any other point on the outside through the center. Just like the diameter of a circle has to go through the center. Okay? So the diameter goes through the center and hits the sphere in two places. If they talk about circumference, they're talking about the circumference of the great circle. The great circle would be right through like cutting the sphere in half into two hemispheres. So half of a sphere is called a hemisphere. And the circle that divides it into hemispheres would be the great circle. Okay, so you can only talk about circumference of a great circle, the circle dividing it in half. Okay, so you're going to learn the two formulas today, one for surface area and one for volume. They're very similar, but you're going to have to find a way to keep them straight. The surface area, of course, would be if you're painting the outside of a sphere. Surface area of a sphere is 4 pi r squared. So it looks very much like a circle, the area of a circle, but it's 4 times greater than that. I'm going to give you the volume formula at the same time so you can see the difference. That is 4/3 with the pi and the r, but since area is squared and volume is cubed, it is 4/3 pi r cubed. All right, so we're going to draw a sphere. And we're going to use a radius, or sorry, a diameter of 8. We're going to do the surface area first. We'll say 8 inches. So surface area is 4 pi r squared. Since you do need a radius, we cut the diameter in half. So the radius is 4. So that would be 4 times pi times 4 squared, which is 16. In terms of pi, that would be 64 pi square inches for the surface area. For the volume, we have 4/3 pi r cubed, so your radius is 4. Depending on your calculator, remember, r cubed would be 4 times 4 times 4. But if you have an exponent key or a caret on your calculator, The exponent key, yep, is usually y to the x or x to the y. You put in the base, the exponent key, and then tell it what exponent you want. Or you might also have the caret. So you put in 4, the caret, and 3 to get 4 to the third. Okay. 4 to the third, I believe, is 64. Yes. So this would be times 64. And the best way to handle this, 4/3 in your calculator, and give you the opportunity to round where you want it at the end, you do 64 times 4 divided by 3, and then round accordingly. Now, if you're leaving pi in your answer, what you should have would be 85.3 repeating, so 3 doesn't go into either of these. You might see the answer as 256 over 3 times pi, because they will leave it as a fraction to avoid the rounding. Or if you want the decimal, you would multiply everything out. You should get 268.1 to the nearest 10th. So when you go to correct and you're looking at the answers and they have a fraction form, because they didn't want to round. So they will multiply the top, and if you divide by the 3 and it doesn't come out nicely, then they will leave it over 3. Okay. All right, let's try another one. You're going to try one on your own. Okay, see if you can calculate both of those. Leave both in terms of pi. So here for the surface area, you would have 4 times pi. The radius is 9, so the radius squared is 81, which ends up being 324 pi square feet for the surface area. All right, 81 times 4. Yes? Okay, for the volume, we'd have 4/3 times pi. 9 cubed is 729. And 9 cubed, of course, is divisible by 3, so this comes out nice. 729 times 4 divided by 3 is 972 pi cubic feet for volume. Okay. That's just calculating the surface area and the volume. Now, what they're going to be doing, because all you need to do the surface area or volume is a radius, they're going to give you They could give you volume, or surface area, or circumference of the great circle and ask you to calculate anything else. What that involves is going back and finding the radius so that you can plug it into the other formula. Okay, so we're going to do a couple of those as well.